So, since we know basic things about current, current is nothing but the flow of electron within the conductor. So, when current flows, when electron flows through the conductor, it collides with the atoms inside, and the motion of the electron will be obstructed. So, there is a opposition for the flow of electron because of collision with the atoms. So, that is known as resistance. Obstruction to the flow of electron is known as resistance. So, there are two factors on which, actually there are four factors on which resistance depends, and there is one more quantity which is known as resistivity or specific resistance. So, we will learn about that as well through this simulation. Okay, since many students were absent during the lecture, so I am recording it once again. You can also download this app and you can just check how resistance depends upon length and area of cross section. So, check this one out. As you can see in this formula, R stands for resistance. Okay, rho is a specific resistance, also known as resistivity. This wala, this is rho. Okay, rho, I am keeping it fixed because it is constant for a given conductor. L stand for length, A for area of cross section. So, as you can see, resistance and length, they both are directly proportional. It means if you decrease the length, resistance will also decrease, keeping area of cross section constant. Okay, and if you increase the length, the resistance will also increase. Here we are keeping area of cross section constant. Now, length is more, it means number of atoms will be more, and there will be more collision of electron with the atoms. So, resistance is more. We can easily understand it. Once we know what is resistance, we can easily understand, right? Because there are more number of atoms, path is quite long, so resistance will be long. Now, let us check how resistance depends upon area of cross section. So, they are inversely proportional. It means if one thing is increasing, another thing will decrease. So, let me decrease the area of cross section. Wire will become thin actually, and as you can see, resistance is increasing. Now, the path is quite narrow. Okay. So, narrow path means there is a less space for the electrons to travel. Collision will be more because because atoms are always there. Okay. So, you can think about it actually. Suppose there is a narrow path and there is a wide path, you will always prefer to go through wide wala because obstruction will be less in that case. So, if I increase the area of cross section, if I make this path wider, so there is more space for the electrons to go through. Okay, this is the way you can imagine it actually. You can understand it a better way. So, area of cross section more, resistance will be less. So, these are the two factors on which resistance depends, provided temperature is constant, because if temperature is increasing, resistance will increase. Okay, so, that is another factor. So, basically there are how many factors are there? Length, resistance increases with length, area of cross section. If the area of cross section is less, if the area of cross section means whether the wire is thick or thin. If the area of cross section is more, it is thicker. If the area is less, it is thin wire. Okay. So, resistance will also change accordingly. Second factor is temperature. If temperature increases, atoms will vibrate at a maximum amplitude and the collision will also increase. So, temperature, area of cross section and the length, these are the three factors on which resistance depends. The fourth factor is material. Obviously, for different materials resistance will be different, but there is one thing which remains constant generally, and that thing is resistivity over here. Okay, resistivity. So, resistivity is a constant here we call it specific resistance or resistivity. So, there are few questions based on specific resistance, define specific resistance and state its SI unit. This question was asked in 2017. This is the definition. Specific resistance of a material is a resistance of a wire of unit length and unit area of cross section. So, what is the meaning of this? Let me write down the formula here. Resistance depends upon length and area of cross section, isn't it? Okay, here will come specific resistance. So, if my resistance is of 1 ohm, omega is the symbol for resistance, resistivity. If my length is unit length means 1 meter, unit means 1 meter, and area of cross section 1 meter square, unit area of cross section, isn't it? Let me write it properly. It's not looking exactly 1. Okay, so unit area and unit length. Okay, so 1 m will get cancelled, and if I arrange everything, so it will be like 1 meter will remain in the denominator, right? क्योंकि 1 मीटर cancel हो गया. So if I arrange it now, this is the unit of specific resistance, ohm meter. So specific resistance is the resistance of a wire of unit length and unit area of cross section. So unit means 1, unit length and unit area of cross section. So this is the unit of specific resistance. Question number 25. Name 2 factors on which specific resistance of a wire depends. Well, it depends upon material and temperature. This table is quite blur although. Here, specific resistance of some substances at 20 degrees Celsius. It means at 40 degrees Celsius, a specific resistance will have different value. Okay, so it means there are 2 factors. One is temperature. Okay, one is temperature, and second factor is materials. So for different materials, specific resistance will be different. Wire AB is made up of copper. A is long and thin, B is short and thick, which will have more specific resistance. So since it is copper only, both the wires are of copper, same material means specific resistance will be same. Now this is resistivity. Although the resistance, okay, which is obstruction to the flow of current, that will be different because length here is different, but we are talking about specific resistance or resistivity. So it depends upon temperature and material. There are few more questions related to resistance and specific resistance. So this question is regarding specific resistance. (20-second) wala, define specific resistance and state its SI unit. So specific resistance is a resistance of wire having unit length and unit area of cross section. SI unit is ohm meter. 21. Name 3 factors on which resistance R of a given wire depends. So length, it depends upon length. Length increases, length increases, resistance increases. Area of cross section inversely proportional to area of cross section. And third factor is temperature. So when temperature increases, resistance increases, length increases, resistance increases. It is inversely proportional to the area of cross section. So when area of cross section is less, resistance will be more. So these are the factors on which resistance of a wire depends.